All right, today I'm going to go over the Unit 8 review over volume and surface area. And I'm going to go pretty quickly because we have 20 problems on here. And I just want to make sure if you have any questions that you please contact me so I can get those answered before you take that test. So number 1 here, the dimensions of a solid block of cheese in the shape of a triangular prism are shown below. Which of these is the best estimate of the volume of the block of cheese in cubic centimeters? So to find the volume, we have to find the area of the base, that big B, times the height. And the name is telling me that triangular is telling me the base is a triangle. So I need to find the area of the triangle times the height. When I do that, I get 174.1905. And the best estimate would be A, 175 cubic centimeters. Number 2, what is the volume of the triangular prism shown below? Again, area of base times the height. When I calculate that, I get 156, so we have 156 cubic centimeters. And if you need to, pause it and you can look at my work. All right, number 3, a tissue box is a length of 11.7 inches, a width of 8.2 inches, and a height of 5 inches. Which could be the approximate volume of the box? So notice I drew the box, labeled the sides, and then I calculated the base, area of the base, big B, times height. I got 479.7. We round that to 480 cubic inches. Number 4, Johnny is giving his girlfriend a ring for Valentine's Day. It is in a box shaped like a cube that measures 1.7 inches on each side. So cube's telling me that all sides are the same length. So I have 1.7 times 1.7 times 1.7. And I get 4.913, 4.91 cubic centimeters. Number 5, a large rectangular box has a volume of 15.75 cubic feet. The box is 2.5 feet long, 1.5 feet wide. What is the height? So I don't know my height. So I put, for the volume, I'm going to put that V is 15.75. I put that right there. I've got my length and my width, but I don't know my height. Calculate that out. 3.75x divided by 3.75, I get 1x. 15.75 divided by 3.75 is 4.2. So we have a height of 4.2 feet. Number 6, a crate is shaped like a rectangular prism. The crate is 1.2 feet wide, 3 feet long, and 4.5 feet tall. What is the volume of the crate in cubic feet? Again, I drew my crate, labeled the sides, and then I did length times width times height. When I calculate that out, I get 16.2 cubic feet. Number 7, some of the dimensions of a square pyramid are shown in the diagram. The height of the square pyramid is 7.5 meters. So it didn't label it, but it gave me the information here. So I put that in my drawing. So I have, for a pyramid, remember we're going to do the 1/3 area of the base times the height. So the first thing I did was determine the base, and that's going to be 9 squared times the height of 7.5. 9 squared is 81, and then I multiplied 1/3 times 81, which is dividing by 3. 81 divided by 3 is 27, and then I multiplied 27 times 7.5. This is a good thing to take care of before multiplying, to just keep your numbers a little smaller. So I have 202.5 square meter, or cubic meter, sorry. Number 8, a net for a rectangular prism is shown below. What will be the surface area when the net is folded to make a rectangular prism? This one here is a little tricky because you have to recognize that when I fold this up, this side here is going to end up here, right? So this side is going to go to here. So right here I have 5 inches. So this side is 5 inches. What I did was I calculated the area of this large section. I don't need to do it all individually. You could have, but I just found that 6 times, and then I looked and I found 5 plus 3 plus 5 plus 3, right? That's 16, so I did 16 times 6 and got 96 for this large rectangle here. If you get the smaller ones, you add them up, you'll get 96. And then for these two out here, 3 times 5 and 3 times 5, so I have 15 and 15. Then we just need to add them up. 96 plus 15 is 126, so we have 126 square inches. Number 9, the dimensions of a rectangular prism are shown in the diagram. What is the volume of the triangular prism in cubic centimeters? So again, we have big B times height. So find the area of your base. That's 48 times height, 34. And I get 1,632 cubic centimeters, C. Number 10, Selena built a model of a triangular pyramid, and it's shown in the diagram. So I'm missing some of this side here, so it took a little bit of my drawing, not to worry. And then it says that the volume of Selena's model is 96.37 cubic centimeters. And it says, what is so it's asking to find the triangular base, so that area. So it wants you to find big B. And it was on your test, it just cut off of when I was printing. So we have 1/3 big B, because we're having a pyramid here, times height. I put in everything I know. So I know the height, I know my volume, and then I would have solved for the area of that base. So the first thing I did was divide by 7.5, divide by 7.5, and I got 1/3 big B is equal to 12.85, and I showed my work right here. And then from there, I took the reciprocal to solve for B, which is the reciprocal of 1/3 is 3, so I multiplied 1/3 times 3, and I got 1, and I wrote down my big B. And then, so I multiplied 12.5 times 3, or 3 over 1, and I got 38.55, which, that's right here. And that was just due to my rounding, is why it was 38.55. All right, number 11. A local carnival sells 2 different containers of popcorn as shown below. So here I have a pyramid and here I have a prism. So we need to know that it's going to take 3 pyramids to fill up a prism, or 1/3 of a prism will fill up a pyramid. It says both containers have the same height and the bases of the containers are congruent, which means the same bases. Which statement best describes the relationship between the volumes of the 2 containers? The correct answer is container B will hold 3 times the volume of popcorn of container A. It's going to take 3 of container A to fill up B. Number 12, an interior designer places a glass square pyramid into a glass cube with the same size square bases. Both pieces have the same height. She then filled the space between the pyramid and the cube with colored sand. How many cubic inches of sand did she use? So the pyramid is empty. The sand is inside the box but outside the pyramid. So I found the volume of the cube here, right? So it's a cube, so that means all the sides are the same. And then I found the volume of the pyramid, which is just 1/3 of the cube. And then I had to subtract them to get the space in between. So 6 times 6 times 6, 216 cubic inches is the volume of the entire cube. Then the volume of the pyramid is 1/3 of that, which is 72. Subtract that, and I found that the volume of the space outside of the pyramid but inside the cube is 144 cubic inches. You could have also taken 2/3 of 216, and that would have given you that 144. Either way will be the same thing. Number 13, a rectangular pyramid and a rectangular prism have congruent bases and heights. The area of each of the bases is 36 square inches. So that's the area of the bases. Which statement is true? Where h represents the height of the figure. So remember, big B times h, 1/3 big B times h for the pyramid. So looking at this has got the same thing, 36h and 36h. That's not true. The volume of the pyramid is 1/3 times 36 is 12, so 12h, and the volume of the prism is volume equals 36h. So B is correct. Look at those other ones to see why they were wrong. All right, 14. Alina drew a model of a square pyramid. The dimensions of the model are shown in the diagram. What is the volume of Alina's model in cubic centimeters? So again, we've got to take 1/3 area of base times the height. I did 10 times 10 is 100. 100 times 12 is 1200. And then 1/3 of that is just dividing by 4. I get volume equals 400 cubic centimeters. 15. A triangular prism and a triangular pyramid have congruent heights and bases. Which of the following is true about their relationship and formulas? So I'm only going to read the true one. The prism is 3 times the size of the pyramid because the volume of the pyramid is represented by the 1/3. V equals 1/3 base times height, and that's big B, so that's the area of the base. So C is the correct answer. Make sure you read through those and understand why the other ones are incorrect. All right, number 16. Aaron purchased a cutout net of a lampshade that folds into the shape of a triangular pyramid. The cutout net is composed of 4 congruent triangles. Aaron intends to cover the outer lateral surfaces of the lampshade. Which measurement is closest to the number of square inches Aaron will cover? So when we're talking about lateral, we are not calculating the base. So I just get the area of the 3 lateral sides. And so they're all the same triangle. I just need to find the area once. So that's 2.5 times 2, base times height, and then divide that by 2. So I get 2.5. We have 3 triangles, so I just multiplied that by 3, and I got 7.5 square feet. Number 17, the net of a square pyramid is shown below. What is the total surface area of the square pyramid in square meters? Total surface area, I need to find it all. Area of the 18 by 18, that was 324. And then I need the area of the 4 triangles, which are all the same. So base times height divided by 2, 18 times 12 divided by 2 is 108. We've got 4 of them, so we have to multiply by 4. And then I need to find the total. I'm going to add the area of the square base and the 4 triangles, and I get 756 square meters. B is the correct answer. Number 18, the net of a cube is shown below. What is the surface area of the cube formed with the net? Again, I did the large rectangle here, and they're all 5. So 5, 10, 15, 20. So that side is 20 by 5. That's 100. And then 5 times 5 is 25 for the 2 smaller, or the 2 rectangles or squares outside of that large rectangle. Add up 100 plus 25 plus 25, I get 150 square inches. All right, 19. The net of a square pyramid is shown below with the dimensions given in centimeters. What is the total surface area of this pyramid? Again, I'm going to get the base and the lateral. Base is 10 times 10, that's 100. And then I need to find the area of the triangles and multiply that by 4. So 10 times 8 divided by 2. 80 divided by 2 is 40. And then I've got 4 of them, so 40 times 4 is 160. Add up area of my square plus area of my triangles, and I get 260. So 260 square centimeters. Last one. A chocolate box made out of cardboard is in the shape of a triangular prism. The prism's bases are isosceles triangles. The chocolate box is a decorative paper wrapping cover, covering only its rectangular sides. So decorative paper is not covering the bases. A net of the chocolate box is shown below. How much decorative paper and cardboard are needed for the chocolate box to the nearest hundredth of a square inch? So to find this, I just multiplied. So 5 inches times, and then I added 2.3 plus 1.9 plus 1.9. I got the entire side there. And when I multiplied that, I got 30.5. So that's the decorative paper. Now the cardboard, so 30.5, this could not be correct. The cardboard is going to cover that and the triangles. That's part of that triangular box there, or the. So I need to go base times height divided by 2. And then I need to add that. And when I do, I get 33.95. So our cardboard is 33.95. So you find the area of the triangles, and then you're going to add them. So this is both triangles, and you get 33.95. So the correct answer is B. I know I went really quickly over that. I don't want to have you have any misconceptions. So if there are any questions, please contact me. I just didn't want to make this video any longer than it had to be. So again, questions, I'll be at my meeting at 11, or I'll be answering my emails. So I am available. Have a great day. Bye.